All right, so chapter 4, the first section is about linear functions. We've done most of this. We're just going to review a little bit about linear functions and also add in a little bit more stuff that you probably either forgot or haven't seen. But a linear function looks like this. F of x equals mx plus b. We already know slope is m, b is the y-intercept. All answers will be in this form. Most of the directions will ask to find a function. In other words, find f of x. So you will always be solving for y, essentially. Okay? And so just keep that in mind. As far as how things will be presented, they might look a little different, but you guys know what to do. So the presentation, instead of me just telling you 2, 4 is on the graph, I might say something like f of 7 equals 4 is on the graph, is on the line. What does that mean? What point does that translate to? 7, 4, correct. The input, or x, is 7. The output, or y, is 4. So they might present it a little differently, but you just have to realize, okay, it's just telling me that 7, 4 is part of the graph. Okay? You might also see something like this. What does this notation mean? Inverse. Okay, we haven't really talked too much about inverses, but all you need to remember is the very foundation of what an inverse function is, and that's just that the x and y coordinates switch. Exactly. So hopefully when you did Algebra 2, that's one of the things that you remembered, is that find an inverse, the x and the y's flip around, right? It's the same thing here. So normally this would be our input and that would be our output. Well, now it's reversed because this is the inverse rule, okay? So just keep that in mind. And then let's go ahead and try, why don't you guys try this example? Find a linear function f of x with an x-intercept of 9 and the inverse at 5 is 7. So what would that look like? Take a minute and work through that. How what? How do you do that?
X-intercept of 9. I can figure out that the point is 7, 5,
And what point is this?
9,
Comma.
5, 7,
It's on the x-axis. It's an x-intercept. Y has to be 0 on an x-intercept, right?
9, 5, 7. Right? 7, 5, yeah.
Okay, so yeah, the only thing that's a little bit different here is I didn't give you the complete coordinates, but you got to know if the x-intercept is 9, right, that the y-coordinate has to be 0. So we have 9, 0 is one of the points, and this is the inverse, so really it's 7, 5 is the other one. And just like any other linear function, how do I get started? Find the slope, so maybe 5 minus 0, 7 minus 9, so that's negative 5 over 2. Okay. Now we're looking for the function. I can't really go straight to slope-intercept form, but I could use point-slope. So use point-slope form to get started. If I do, let's use the first coordinate, since that's got a 0 in there. It'd be y minus 0 equals the slope, which is negative 5 over 2 times x minus 9. And we can, y minus 0 just turns into y. Distribute there. So that's negative 5 over 2x plus 45 over 2. And the y, that is our f of x. So the last thing you're going to do is just replace this with f of x. Any questions on that?
You could also just plug in 7 and 5 into slope-intercept.
You could just plug it into slope-intercept form and work backwards. Correct, yes. Okay. Make sense? Let's talk about something we call percent error. Percent error, you're just trying to figure out if you compare an estimate or an approximation to what it should be, what the error is. And so you can do that by doing the absolute value of the actual value minus the estimate or the prediction or the approximation, let's call it, divided by the original or the actual value. Then obviously times, oops, kind of ran out of space. Multiply it by 100. So we want the percentage. Okay. You actually have, it may not have been called percent error, but this is the exact same formula. If I were to change this to percent error to percent increase or percent decrease, it's the same exact thing. If this were percent increase or decrease, you would do original and then subtract the. You probably do this in chem, yeah. Okay, but it's the same exact thing. So knowing this formula and what we've talked about so far, you should be able to do this example now. Okay, so let's say that f of x equals 0.451x plus 78.152. Let's say that is, or it models the average on the final exam where x is the number of years since 2010. So I'm going to ask you to do two things. I'll give you a couple minutes. First, predict the average in the year 2020. And then once you have that, find the percent error if the actual class average is 83.4%. So here's a model. Use it to predict what the average is in 2020. And now, supposing that this 83.4 is the actual average, what was the percent error from our model? All right, let's start going through. How do you do part A? Exactly. Plug in 10. Nobody actually plugged in 2020, right? If you do that, the percent average is pretty ridiculous. Okay. What do you get when you plug in 10?
662.
Okay. Pretty good class average. Part B.
Funny.
Find the percent error if the actual average was 83.4.
What's 83.4? And actual value.
Minus
Minus
the
82.
approximation.
Over the actual value of 83.4.
Good.
Times 100. I don't have my calculator.
88%. 0.80. Okay. 0.88. That sounds better.
Oh.
It's like 0.0088, whatever. Multiply by 100, right? So it's just under a 1% error. That is pretty good. Does that make sense?
Yes.
Cool. Let's move on. The last topic.
I like this. This is easy. It's not easy, but it's like good. Oh yeah, I can bring cosine and sines of using this class.
Lines of best fit. I know that you've talked about this in your chemistry or physics classes, but we're going to do better than that. So let's just say, here's some data. it's pretty clear that, you know, there's an upward trend, right, as we move along this graph. Okay. How do I approximate or approximately draw the line of best fit here? So here and there. Yeah, I would try to kind of go through the middle. So maybe something like this. So that you kind of roughly have about the same amount below or above, or okay. So this red line, and you know what? In your science classes, I imagine you probably get out a ruler and you try it, right? Do you actually use the calculators at all? Oh my goodness. Okay, let's talk about the calculator, shall we?
Should I go get it?
Yeah, go get it. So I'm going to give you a way. So the goal here is to find this on the calculator. Find this equation on the calculator. So not only can we visually approximate it, but we could do better than that. And so here's an example. So let's say we have some data. Okay, we're not going to overcomplicate it and, you know, make it a word problem. I mean, you will have word problems, but just to understand what's going on, let's just look at a basic table of data. Let's say x is 50, 51, 52, 53, 54, and 55. And let's say our y values are 105, 110, 114, 118, 126, and 131. Okay. So if you don't have your calculators out, you should, and make sure you're following along. Okay. First, this step that I'm going to show you, you really don't have to do it anymore besides this one time, because once you do it once, your calculator will always have this feature activated. So first, the catalog menu is located where the 0 button is. So press second and then 0. And that takes you to the catalog menu. What you're going to do is scroll down until you get to where it says diagnostic, and you want to hit diagnostic on. Okay? It's all the stuff your calculator does. Yeah. All you guys know how to do is add, multiply, divide, and subtract, right?
Yeah.
The things that you're supposed to know how to do without a calculator.
Oh, wait, off or on?
Make sure, yeah, we want it to be on.
Oh, on.
Okay, it should paste it automatically on your home screen. You hit enter, and you should see a little message that says done. Okay? You don't have to do this step. I want you guys to hear this. Please don't do this every time. Once it's activated, it's on. You don't have to do this over and over. Now, if your batteries die and your calculator gets reset or something, then you might have to do it. But otherwise, you should be all right. Once you've done that, here's the basic roadmap. Okay. So first, you're gonna put this table of data into the calculator, and you do that by pressing the Stat menu, and you hit Enter on Edit. And you should see L1, L2, L3, and so on. Does anybody not see L1 and L2? Okay. Now, you don't have these in there yet. You might have other stuff in there. You might have nothing. But here's what you should know how to do. Okay? The fastest way to get rid of any information, like if you want to put new ones in there, if you go up to L1 and press Clear, and then hit Enter, it automatically erases them all.
I'm so smart.
Okay?
I hate. Did you do that?
Otherwise, the other option is you press Delete individually, and you can do it that way. Okay? Now, what you don't want to do is highlight the column and then press Delete. Because now what that does is it completely gets rid of L2. And we don't want that. Now there's always a way you can insert it. You go insert and then L2, and it puts it back in there. But you don't have to do that. Just remember, highlight, clear, enter. Okay? Highlight, clear, enter, and now you can just start putting in the data. You shouldn't have to do that.
You did though.
You actually deleted it after I said you don't want to do this.
No, I didn't. But just in case I do, and I'm taking a hard test.
The opposite of delete is insert.
Oh, yeah.
So that's where you would go. So second, insert, and then whoop, you'd have to go up there, and then it inserts a new column for you. Okay.
Thank you.
And then you see in blue right here,
Yes.
L1, L2, L3, that's how you put it back in there.
Thank you. I just feel like I'm on that stuff.
No problem. Whoop.
You're gonna go up to your
Okay. No, if you come up to me during the test, I'm going to go, I don't know.
And I'm gonna cry.
And I'll hand you some tissues. That's okay.
Can you actually get some
Okay. So let's go ahead and put this X column into L1. Don't mind my goofy class, YouTube. They're just, goofy.
You're recording?
You're recording?
Yes.
No
Oh.
way.
Wait, you wanna add my Snapchat?
No.
Martinez_Brian.
Stop. I can't put information that's identifiable on YouTube.
No.
Oh, you're
Call me at 911.
We're gonna see your video real quick. No,
Think about it.
Okay. Does everybody have this information put in there? Is everybody good to go? Okay. Quit. Second mode. That's the quit option. You should be back on the home screen. Okay. So far we've gone to stat. We went to edit, and we put the X values into L1 and put the Y values in L2. That's all we've done so far. That's a 2, by the way. Second thing, we're going to go back to stat.
What?
Back to stat. And instead of editing or create, we're going to calculate now. So we're going to go over to calculate. And now your calculator has the capability to do a whole bunch of stuff. 1 variable stats, 2 variable stats is where you can do like mean, median, mode, range, standard deviation, all that stuff for all this stuff. We got linear regressions, quadratic regressions, cubic regressions. Right now we're just doing lines of best fit. So we're going to go option number 4. Okay, and then you should see a display that looks like this. If for some reason, so this is for you, Brian, you forget how to insert L1 or L2 because you accidentally deleted it, you can tell it where your X and where your Y is. So maybe you have an L3 and an L4. You can just tell it it's L3 and L4 right here. Does that make sense? But the default is L1 and L2. So if you just always have that in there, then it saves you time.
How'd you get there?
Wait, can you show me how you got there?
Once again, it's right here. Stat,
Oh, number 8.
calculate,
Four.
calculate, and we went option number 4. Linear regression, number 4. Everybody see it now? Okay.
Wait, let's see the, oh, never mind. I see.
Scroll down to where it says calculate, hit enter, and it should give you the line of best fit. Okay? And so now let's write this down. So y is going to equal, what's the slope?
5.2.
5.2 x. Y-intercept is negative 155.6. This is actually 6 repeating. Your calculator just rounds it up.
Why is mine off?
Because you probably inserted something wrong. Go back to stat, go back to edit, check all your points and make sure they're exactly the same. Wait for it.
They are. I'll tell you.
You put 114. Oh, no, there's 114. Is it 120 or 126? Then yeah, you're good.
And what do you see?
Chart. I see. Yeah. My BS negative 157.
Bring your calculator up here.
Calculator, don't take this calculator.
Let's see what's going on here.
It's your sisters. Cheater. Yeah, cheater. She programmed it wrong. She put it to see you come real. That's identical to me.
Because you did a linear regression with L1, L2, L2. I'm not sure.
Oh my god!
So let's try it again.
I
Stat,
exposed a video.
calculate, linear regression. Yeah, don't have anything here. Frequency list. Now you should be good. There you go.
Okay.
Alrighty. So there's your line of best fit. Okay. Once you have this line of best fit, you can do some pretty cool stuff with it. Let's go through it. So number one, okay, let's go to y equals, whoops,
Wait, how'd you get back to that?
just quit, and then go to y equals. Okay. These features up here, plot 1, plot 2, plot 3. This is how you actually plot points in the calculator. Right now, we have 6 points on the calculator. If we want to see them, you can go up, hit enter on plot 1, okay? And now change your window to match so that you can see this. So for example, I would probably change this maybe to, let's go 45 for a min and maybe 60 for a max. That way I can kind of see it. Does that make sense? And then for the y min, maybe 100 to 135. Okay? You can certainly change your scales to be better than just going up by 1 tick mark each time. Maybe go up by 5s. Maybe go up by 10s here. Okay? So now if you hit graph, you should see the data points.
Oh my. What?
That is magic.
Do you
Good job.
think my error range?
Good job.
All right? Does everybody see this?
I like a
If you don't
calculator magician.
If you don't see this, don't worry about it. It's not a huge deal. I can show you how to work with it later. But now here's what I do want to show you. This is the important piece. Okay? So you could certainly, you can just type this in. This isn't so bad, right? But imagine doing a linear regression where it was like 5.131593 and typing all that in. That gets kind of annoying, right? You can paste this equation into it automatically. Here's how you would do that. So to paste into y1, now I'm going to have to remember, I think you press vars,
Let's see you do it.
you press vars,
Wait, where?
the button that says vars, V-A-R-S, variables.
Okay, sir.
We are doing some statistics, so I'm going to go statistics.
Yes, sir.
Equation. And in the equation menu, you see this regression equation option. Hit enter. It should paste it automatically in there for you.
Yeah, boom, got it.
And so now if you hit graph, not only will you see your points, but it graphs the line of best fit, and it sure does look pretty good. Okay?
What does invalid PIM mean?
That means you don't know what you're doing in the calculator. I'll help you in a minute.
What about a blank screen? Wait a minute.
Again, don't worry about the last piece. If you can at least get the equation for now, that's all that matters. This we can talk about more
It doesn't matter.
Is this
tomorrow.
Yeah.